Okay, silence again. Time to stop talking. Come on. Okay, no talking, please. This one we did last period, so I'll not rewrite it. I'll ask you to. You're good. What do you need? Yeah, you just to get your scanning sheet filled out. There we go. So you gotta go today. You guys
just go right through.
Hey, look up. Quiet. Hey. Never asked on every. There, look up. So in every integral, you divide by divide by the width of the integral. I'd be a little cautious on that. There are some questions that ask for an average where an integral isn't even involved, so that's different. But if we're finding the average value of some function, yeah, we need to integrate that function and then divide by the width of the integral. Okay, these are the steps. This one's laid out pretty nicely. Does anyone have a question on anything on the board? Like anything about it?
What number is this?
23.
Yeah, I got wrong.
Please, but no one talks so I can hear Annika.
Okay, so when I was doing it at the end, when I was gonna divide it by 2, I was wondering why the 2 doesn't switch to U. Is it because you already found all of it?
Oh, I got you. See if this helps. If it doesn't, Annika, just keep asking.
Okay.
Okay, the first thing you said is really good. We're trying to start with this integral here and transform it to this one. The 1/2 is just a multiplying constant. So it's not a value of x, it's not a value of u, so it doesn't really, we just kind of bring it along.
Okay, I just did that at the end. That's kind of good.
No worries, is that okay?
Yeah.
And you can do it at the end as well.
Okay.
Because ultimately what you're trying to do is this integral and then divide by 2. So that's fine, either way.
Okay, cool. Thanks.
Take it for Annika. Anyone else have a follow-up question here? You move by raising hand, need more time to look at the board. Okay, keep going. Just so you know where we're headed. So today's homework assignment was already texted out. It's the last kind of problems in the pink, although I haven't assigned every pink problem. So it's not like finishing the pink, but it's pretty close. Then we have one more packet, 2 assignments, 1 or 2 assignments from that packet, and then a test. probably better for everybody.
Okay, well, so on number 20, it says if the position of a particle on the x-axis at time t is equal to negative 5 squared.
To like make sure that.
So that one you don't have to do an integral, right? But what makes you have to do an
Oh, gotcha. Really good comment. Hey, need silence. Perfect. Okay, let's do this one first, and comparing it to 23 will make more sense. It says the position of the particle is given by negative 5t squared. So from that, I can write down that the formula x of t is going to equal negative 5t squared. And you're correct, Chad. It says find the average velocity of the particle from 0 to 3. There's two ways you can solve this. The way you're thinking of is, well, let's just go find the position at time equal 0.
Yeah.
So I write that down so everyone can see it. Turns out to be 0. Let's go find the position at time equal 3. Let's see, that'll be negative 5, 3 squared. So 45, is that right?
Yeah.
Negative. So from time 0 to time 3, the position changed by what amount? Negative 45. The particle was somewhere, it's now 45 to the left. I need one or two if that makes perfect sense. Come on. One or two if that makes perfect sense. The particle is 45 to the left. Now, how it got there, we don't really care. All we care is the particle was here at some location, time equals 0. The particle's now over here, new location, time equal 3. And this change in position was a negative 45. So average velocity is saying, well, if the particle had moved from here to here with a constant velocity, what would that velocity have to have been? Well, how much time elapsed for it to get from here to here? 3 seconds. So negative 45 divided by 3 is definitely an average velocity of negative 15. You're good with that, right? Awesome. You have a question about that idea? You know, the other way you could have done it, which will tie it better to 23, Chad, is this. 2 tickets for really a very good question. I could have said, okay, x of t is my position, and it's equal to negative 5t squared. But I could find the derivative of the position quite quickly. Someone raise your hand, pick up the ticket. Tell me what would the derivative of the position be in this particular case, Chad?
Derivative would be negative 5 parentheses t cubed over 3.
Oh, that would be anti-derivative. Oh, yeah. No worries. Ticket.
Okay.
Sarah.
Would it be negative 10t?
There you go. No worries. So my formula for velocity is negative 10. Come on. My formula for velocity is negative 10t. Questions there? Okay, somebody answer this. I'll pay you. Chad showed us one way to find the average velocity. It's correct. Always works. Now that I know a formula for the velocity, there's another way for finding the average velocity between time equals 0 and time equals 3. Chad's in. Who else? Take it from Chad. What's the other way of finding the average of the velocity? Emily. Ellie, sorry. Oh, that's what we did up here. Oh, be careful. Yeah, we can't take 2 different velocities and subtract them and then divide. That'll find the average acceleration, actually. That'll be how the velocity is changing. What's the other way for finding average velocity?
Oh, wait. I don't know.
Isn't that when you use the integral?
Yeah, to find the average of anything. Hey, come on, pay attention. Make sense of this. To find the average of anything, you integrate what you're trying to average. If I'm trying to average velocity, I want to integrate the velocity. So I integrate from 0 to 3. You get t. And you need to see this connection. Do not check out on this one. You need to see this. It's going to show up again. It's a really good question. You integrate the velocity, and then you divide by the width of the integral. So we divide by 3. You give me 1 or 2. If this box right here, it doesn't make sense. Showing 2 is fine. There's no shame in that. But does that make sense? If I want to find the average velocity, that green box will find it. for that, for the room. So that means my average velocity, oh wait a minute, let's just do it this way. But hey, we've been studying this for the last 2 days. If you take the integral of the velocity, one person please, you take the integral of the velocity, what are you finding always? Say it louder, say it louder. Change in position. Well, the way to write change in position, we've been talking about this, is to write, well, let's find the position at time 3 and subtract from that the position at time 0. That gives us the change in position. So this integral is equal to this subtraction. But because we divided the integral by 3 to make this truly equal, we would divide this by 3, which is what we did up there.
So basically it's like the first part, because we already have the position, the equation just like skips all the.
Yeah, it's perfect. It's perfect. Whereas over here, Chad, they said find the average of this function. They didn't really tell us what it was. But it's more like they're giving you the velocity.
Okay.
And we don't have the position, so we need to do the integral. Now in the process of doing the integral, we actually found the position formula.
Yeah.
Because it's right here. It's I've got to scroll down a little bit, but yeah, you're seeing it perfectly. This is the position formula. And you plug them in and subtract. Perfect. Sarah.
So I don't know how I'm getting to the 9 to the 3 over 2, and then how does that equal 27?
Say it louder, Sarah.
So the 9 to the 3 over 2, the thing at the very last, yeah. How does that go to 27? So
Gotcha.
I put it in my calculator, and it's like 4.327.
And be careful how you enter it. So you'd say 9 raised.
Wait, just kidding.
Okay, sitting is good. You good now, Sarah?
Well, okay, but I'm not gonna have my calculator on the chest, so how do I know still?
Perfect. I wasn't sure of your question, but that's great. You say you did it without the calculator. So you did get 27 on the calculator, right?
Yeah.
Got it. Okay, when you see a fractional exponent, you have to do 2 things. Power and root. So it's pretty intuitive. If you guess wrong, it's fine, Sarah, but which one would you expect to be the power, the 3 or the 2?
The 3.
The 3. It's fairly intuitive. The root is the lower one. So you get to choose. Would you like to do 9 cubed first, or would you like to do the square root of 9 first?
The square root of 9.
Good choice. What is the square root of 9?
3.
3. Now you take the 3 and cube that.
Oh.
So what's 3 cubed? 27. That makes sense. Good work.
Do you do it like, so like, you have 9 and then the first power, wait, multiplied by 9 is a half power, if that makes sense?
You still have to do the cube somewhere, but
I'm trying to think if I have it.
okay, write it down.
Yeah.
Chen.
So, well, on number 20, I don't know how I managed this. I don't know if it's a matter of just the problem. I managed to be able to do this by sheer dumb luck. But the negative 5t squared, I took the antiderivative of it and got the right answer. But
Sheer dumb luck.
Okay.
Yeah. It happens. No worries. Happens to all of us. Yeah, that doesn't make sense because if you're taking the antiderivative of the position, I don't know what you're
I'm
doing.
positive like it works though, because I went back to my math and it worked on this problem, but yeah.
So what really happened was just coincidence.
Yeah.
Worked for this problem doesn't mean it's going to always work. So, good question. David, please. Yes. Is everyone good here? Go. Which number? 40. Specific question, what we just talked about?
I just don't really get like what we're supposed to do.
You're okay. Okay, part of the reason I put this on the homework is I'm not trying to fool anybody or trick you or get you frustrated, but I am trying to prepare you for the AP test where you don't have any idea of what you're going to encounter. And so giving you some problems that you've never seen before, we just have to keep doing that. In fact, after this next test, we're basically into practice test season, meaning there are no more units or anything. It's just a series of practice tests. Now, there are a few concepts we still have to learn, but because they didn't fit well into a unit, we just learned them kind of intermixed with practice tests. And you're going to watch it's really like a 2-month, reference to Lindsay and Braden, it's a 2-month weightlifting program, okay? Where you just get stronger and stronger every day over the 2 months until the AP test arrives, and then you know you're like really strong. So, sorry, I couldn't resist. You all right back there? Okay. Good. You need to step out for a drink, please. It's fine. So Bailey, it's an antiderivative, so I think formula. Formula doesn't fit. Somebody comment, hey, why does the formula not work? Come on. Gotta get you to focus. Deborah's in. Who else knows? Come on. Bailey's in for tickets. Deborah and Bailey are in for 1. Who else knows why won't the formula work? Sarah?
Because it's, so I thought that it was the AX plus B one, because that's just what it kind of looks like, but it's X squared in the parentheses, so then that doesn't work.
It's perfectly set. And what you did would have been exactly what I would have thought you might have done. 1 second. Is think AX plus B, but because it's squared, it doesn't work. How do you think?
Can you just divide into 2 parts? So you get X squared plus 1, X squared plus 1, and then do both of them?
Nicely. Kind of. But you're on the right track. Let me say one more thing. Take it for Heidi and Sarah. So the formula doesn't work. Any question about that? Okay. The next thing I would think of is U substitution. But I don't really see 2 functions being multiplied. So you want to comment on that? Oh, please. Oh. You can think of it that way, and that's kind of where Heidi was going. So let's write that down. Take it for Ellie and Sydney. It's thinking the same thing, right, Sydney? Are you thinking something different? Don't worry. Heidi? The one thing I want to make sure you don't do, because it is illegal, is you can't split this into 2 integrals. Because there are 2 things being multiplied, so that's not allowed. So don't do that. There are 2 things being multiplied now, but watch this. So there they are. So the choice of U would basically be X squared plus 1. If I take the derivative of that choice, I get 2x. That's not equal to the other multiplying function, so that means dead end. So U substitution is not going to work. So you have to think of something algebraic, like some sort of manipulation that can be done to just change things into a friendlier form. Deborah knows. Ticket. Who else can see it? Sydney's in. Ticket. Amanda, Sarah, these are all tickets. Derek. You put your hands down. You're okay. Who else knows? What can we do? Bailey. Huh? So I multiply it out, and I get a brand new antiderivative that's x to the 4th plus 2x squared plus 1. With 3 things being added, I can just take the antiderivative of each piece. Perfect. Bailey, question? Please, Chuck.
Did you do the squared in the original antiderivative?
Explain what you mean.
Like, so, like originally it's the antiderivative of x squared plus 1 squared. Could you distribute the squared? Not really distribute, but like do it. Like if you could do like x squared squared. I don't know how to explain it.
Just keep talking.
So basically, how to describe it? I don't really know.
Tell me exactly what you're thinking to
So
write.
like, you would, so you start out with x, or the antiderivative of x squared plus 1 squared dx. Could you do the original, like could you square everything in the parentheses first?
Tell me what to write.
So the x squared is x to the 4th a, and then 1 squared is 1.
Do you want to write plus?
Yeah, plus 1.
Is that what you're thinking?
Yeah, but I don't think that would work.
You're doing great. Take it. Hey, everyone look at this. Please look. Chad gets 2 more for this one. Good day.
Sweet.
Yeah, this is illegal, but it's commonly thought that it's legal, so it's a good question. No, it's a very good question, but it's not legal. It doesn't distribute. The only way to distribute really is to multiply this. Good question. So don't do that. No worries. Not bad, just a common mistake. Anybody else? You want to have a different, Bailey, you get there?
Yeah.
You want to have a different question that you brought me into class? Oh, please.
Where'd you get the 2x squared? Like, where did the 2 come
Oh, sorry. So the steps of multiplying it out, which I didn't really show, would have been, let's erase this. I'm going to need you to talk me through it, Bailey, then you'll see it better. Okay with that?
Yeah.
So I say this times this is what? Then this times this is?
X squared. Oh, okay.
You see it now?
Yeah, so there's 2 of them. Okay.
No? Please.
I don't know how to word this, but my like biggest problem with these problems is like, I figure out like I can't do it through the formula first, and then I'll move on to U sub. And just as I'm going through, I'll like find one that I think works, and then sort of force it by doing all sorts of weird stuff instead of like doing what's actually right. Because I feel like I have a hard time just like going through all of them before I can find the right one. Does that make sense?
Kind of. If you want to sit down by me sometimes, show me the work, I can maybe help a little bit. The other thing to remember is that when you're doing a U substitution, the mental checklist to go through is, do you see 2 functions multiplied? From those 2 functions, you look at them and identify that they're of the right form. And seeing what form they're in will tell you what the choices of U need to be. Then you do the test to see if it works, and then you kind of go from there. But please go.
Just on the order of +1 plus x and the derivative, is that true for every constant or just more?
Yeah, because of this, Mikkel. So let's just make a little quick table, kind of to illustrate the idea you're asking about.
Okay.
So let's say f of x and f prime. So the idea is that if the f prime value happened to be 1, the antiderivative will be x, because the derivative of x is 1.
Okay.
There'd be a plus constant, but you okay to leave that off for a second?
Yeah.
So now if the derivative were 2, well, what the antiderivative must have been would have been 2x, because the derivative of 2x is 2. If this is 1/2, this is 1/2 x. Any question?
Yeah.
Take it from Mikkel. Check.
Is that just something we have to memorize, or is it the steps?
You can do a rule, but it's easier just to memorize. The rule would look like this, Mikkel, Chad. Finding the antiderivative of 2 dx. True? That's the same as the antiderivative of 2 multiplied by x to the 0 power. Because x to the 0 power is 1.
Oh, yeah.
2 times 1 is still 2.
Yeah.
So now you pull out the 2. Now you can use the rule. It's just more work than really necessary. So it's just easier to remember that the antiderivative is just 2x.
Yeah.
Yeah, and I could have written down a rule like this as well. I could have said the antiderivative of any constant multiplied by dx is just the constant multiplied by x. I just kind of thought memorizing it's about as easy as writing it down. So, follow-up question? You bring it. We're gonna have a different question you brought to class.
Yeah.
Cool, new stuff. So, Turn to number 10 in the pink, please. Turn to number 10 in the pink. No, second. Good. I like it. You've done this problem before on your calculator. It's just that now you've got to learn how to do it without a calculator. So you just have to read carefully, make sure you can understand what they're describing. It says the area of the region bounded by. The words bounded by on the AP test refer to the following are going to surround some region. So we just start identifying what the boundaries are. So to do a little wake-up exercise, it's a good way for me to check if you're understanding or not. It says one boundary is the line x equals 0. So please do one of the following. Say that x equals 0 looks like this, or say that x equals 0 looks like this. Go, come on, make the motion, make your motion. Come on. Think about whether you go like this or go like this. Some people are going sideways, people are leading the music. Yeah, that's always interesting to watch young men try and lead the music. It's like, good grief. Where is the beat? I was in drumline in high school. I can find the beat, but you cannot. So there's this old movie where, it's an old movie. Anybody seen Mr. Holland's Opus? Too old. He has a kid it's in the band, right? And the kid is a really good football player. It's an old-fashioned story. He's got to get credit for music. And so he's trying to help him get the music credit so he can be in the football team, you know. So he literally puts a football helmet on his head, and he hits it with a little hammer. Like, come on, get the beat.
You know Jake Newell?
Oh, yes.
He's the chorister in the board. Like, that's his calling.
Nice. I know a religious, I'm not supposed to be biased towards any sort of denomination. I know a religious congregation where a 14-year-old is the organist.
What?
And he is good.
Wow.
Poor kid.
He is really good. You play whatever, just sits up there, you know, never misses a beat.
Wow.
Popping them out.
Is that in
Oh, really? That's cool. Yeah, same thing. It's him and his name. All right. Look up. That was a good wake-up exercise. Okay. X, look at me. Look at me. Come on, do it with me. This is x equals 0. Hey, look, watch me, watch me. Here's why. Look at this line. Everywhere along this line, are the x-coordinates different or are the x-coordinates always the same?
The same.
And they are always 0. Okay, draw that in your notes. The other boundary is x equal 2. So someone raise your hand and comment on where the other boundary belongs and how I draw it. Please, Heidi. Nicely done. Heidi. Someone comment on where is the third boundary, y equals 0, relative to those two boundaries. Ellen? Nice. Okay, now, next thing. I've got to figure out y equals e to the x over 2. So I want to remind you of something you're all supposed to have memorized by now. E to any power is always somebody said with that power. E to any power is always. Who said that? Positive. 2 for Bailey. Everyone else needs to get that memorized. E to any power is always positive. He said in first period, it said e to the something is always, and somebody very astutely and correctly said something. Yeah,
Minus 2 tickets.
That's right. Put them out. I'm taking them away. We're gonna have a little burning ceremony right now. Pull out my lighter and just torch them. Those who gave me the cafe thing, pull out my creme brulee torch and poof, no more tickets. All right.
Can you bring that to class?
Or you could be like.
No, bring the fried ice.
What if I
Or
was-
I get
Yeah,
jealous.
I pushed it.
Bring the ice. You need to cover
Well, actually,
the
1,000 points down my
stickers.
file. 10,000. Get out. Get out.
Look up, come. Very distracting, my apologies, my bad. Hey, look, since e to the, it is crucial, you've got to remember, e to the something is always positive. It shows up in many, many AP questions. E to the something is always positive, never zero. Therefore, this curve has a bunch of points, and I don't happen to remember what the points look like, and most people don't, unless your name is Colin Allred. He just remembers everything. Yeah, he's 14, I think, but yeah. Watch. Hey, come on. Hey. Come on. So, waiting. Good. Okay, so every point is above the line. I don't remember what it looks like, so here's what I do. You ready? I close my eyes and I just draw. Okay, good. Yes! It doesn't really matter. It don't matter none. Okay?
What don't matter?
What's important is this. We know that all the points are above this line because they're all positive. That's all we care. It has some shape. I don't care. I'm supposed to find the area. It's good enough to figure out what to do. So finding area means I'm going to do this. Find this area. Well, you've done this before. You just used a calculator. So you remember the formula is, I'll write it down for you. Let's see, area is always going to equal the integral. We're going to take the y-coordinate at the top, subtract the y-coordinate at the bottom, multiply by dx, and integrate from the first x-coordinate to the last x-coordinate. So, looking along here, thinking of narrow rectangles, someone raise your hand and please tell me, how would you compute the y-coordinate at the top of any of those rectangles? Heidi, please, all over it.
Would you just do an integral from 0 to 2, and then you do e, so let's say the top line was f of x equals to f of x minus 0, or yeah, f of x minus 0.
That's perfect, Heidi. And the f formula in this case is just that e to the 1/2 x.
Okay.
And since I have to do it by hand, I'm going to go ahead and write that one down. Take a Heidi, it's perfect. You would want to talk about it. Give me one or two if everything on the board makes sense. Come on. Show me one or two if you are feeling good about everything that we have written on the board. If it's two, just show me two. But take it for the room. Cool. At this point, we'll let you finish it at home. But all you have to do is find the antiderivative, use the formula on this one, plug in and subtract. Question. Next example. Oh, sure, as long as you want. Please do. Antiderivative. Since we're doing it in. Yeah, Bailey. The only thing different about tonight's homework versus the previous homework is that they're asking you to do something extra to set it up. After that, it's the same. Please.
So we can combine like the area and
Yeah.
you can do all of them.
Yeah. Think of it this way, Ty. Hey. I mean, all of this is integrals without your calculator, so it's all using the antiderivative method. The thing we did here had nothing to do with integrals, really. It's just how to set up an integral to find an area. Just an extra step. Perfect. Take it for time. Oh, please.
Okay, so I did it, but I don't understand the answer how you did the 1/2.
Just keep going for a minute. which you kind of kept going, which is
Or I mean,
fine.
the 2 out front of the 1 half.
You're good, hold on. So this is e to the ax plus b. So the antiderivative is 1 over a. And Ellie, what's the a in this case?
Oh,
1 half.
sorry. I just did.
You good now?
Yeah.
So that-
I was just doing this for the, like I got
Oh, hold on. Are you good to hear? You good for the next year?
No.
So what? So 1 over 1 half is the same thing as 2.
Wait.
Question?
Is that why you wrote it instead of x over 2, 1 half?
So the mistake most people are making is, look here, okay? You cannot use the antiderivative e to the x rule. You have to use the e to the ax plus b rule. Because it's not e to the x, it's e to the a times x. And in this case, a is 1 half.
on the last one, when you said the boundaries, how come it went from 2 to 1? 2 0 then 1 to 0.
Oh, if you notice that, who noticed this?
Yeah.
Who showed it? Come on. 2 tickets, it's a mistake. Nicely done, Lindsay. No, really. Well done. Just my bad. Thank you. No? So at the end of the year, I wanted to mount a shirt that you're wearing on the wall, framed and everything, Sarah Louder. And I'll be waiting for that one of my shirts. I don't want your. Look what hers says. It's awesome. Like, what does it say?
It says,
Go up to the front and be a mom.
No, she's good. Just say what, Sarah, what does it say?
Don't talk, just act, don't sleep, just don't
Amen.
Amen.
My
Amen.
more inspirational shirt, would you take it off?
Amen.
Yes.
There's no inspiration.
I can be very inspirational.
That was dang good. I have not found very many that are that good. Taco Bell.
I know.
You work at Taco Bell?
No, I just love
Oh.
Hi. I'm gonna get my. What are we doing?
Oh, you still want that up there?
Yeah, I want it up there.
I
It's
totally
proud.
That's an honor.
There's only a few on the wall, man. Chad knows. There's only a few on the wall.
Tell me that. Put it on top.
Here, look at 11, please. Come on. Hey. Listen, hey. Okay, come on, focus. Just keep reminding yourself that you don't learn well just sitting passively. You learn well by being actively engaged. So, some sort of song about that.
Thank you, sister.
Very nice. Very nice. My mic, I can bring you the mic. We can tie the microphone into the sound system. Sing away.
Sing it so we can hear it.
Yeah, Chad, I missed your voice.
Yeah. That's fine.
Quiet. Okay, everyone, please, look at the problem. I want to see everyone's hand on this one. Look at the problem. There's something distinctly different about, there's a bunch that's the same. There really is a distinct difference between how this problem is described versus the last. As soon as you see it, show me your hands. Just one. Something very distinctly different. Okay, everyone who's got their hand up, talk to me, Lexi.
There's no like boundary, like x equals 0.
You're doing it, the way you're doing it is how I would have thought of it. Like the last one, like x equals 0, x equal 2. You know, you kind of can build the boundary.
Yeah.
Here, there is a boundary. It's just kind of described in a different way. Somebody noticed that? Come on, show me your hand. Ticket 2 for Lexi. And the key thing is only 2 things describe the boundary. Okay, the only way for 2 things to create a bounded space is for those 2 things to be intersecting, to surround some space. One or two, if that makes sense. 1 second, Chad, sorry. So we've got two curves. One of them's a line, but who cares? They've got to surround some space, so they've got to intersect. Take it for the room. Talk to me, Chad.
So like, don't they have to intersect at 2 points? So like, the first one will like go up and then like come back down. The other one will cross 2 points.
Nice.
Okay.
Listen to Chance. Hey, they've got to interact in some way that they cross twice. Otherwise, they won't enclose a space. 1 or 2, if that makes sense. Come on. They've got to interact in some way so that they cross twice. Otherwise, they won't surround any space.
Why?
They've got to cross twice. Like, think of it this way, Derek. If here's a curve, here's another curve, and they only cross, they don't surround any space.
Yeah, but if it gives us like an X, like a limit, then it wouldn't matter, right?
Well, yeah, that's why I'm on the last one.
Yeah, I'm just.
Yeah, you're good. The last one gave us, hey, this is perfect. The last one gave us 4 boundaries.
Yeah.
1, 2, 3, 4. That surrounds the space.
It's only 2.
2 boundaries, they got to interact.
Okay.
Bailey, please.
So how do you know it's not switching like the x-axis? So
Oh,
they're like
awesome.
coming off of that and
Awesome, perfect. Hey, if the x-axis, yeah, all right.
Same.
If the x-axis were one of the boundaries, they'll tell you. They'll tell you. It's perfect. Please, sir.
Is it gonna be like, so I'm kind of picturing like a half moon thing with the line?
You are pitching it perfectly. Again, I don't really care. So first step, hey, everybody do this first step. Got to find the intersection. So one person at least, I hope, remembers from some previous class, when you have 2 curves, what do you do to find their intersection?
you just said
Nicely done. So we write down, take it for Sarah. Okay, next thing to remember. This is a quadratic equation.
Yeah.
And to solve a quadratic equation, you don't like isolate x. Instead, you get everything together and factor. So bring the 4 over. Factoring with a leading coefficient of -1 is not easy. So I'm going to multiply the entire half of the equation by -1. Which means I technically would need to multiply the other half by -1. Since it's 0, it doesn't really matter. Sarah, please.
Well, isn't it still, is it just x squared,
Huh?
not negative x? Oh, just kidding, I see.
Are you with me?
oh yeah, I thought you were
Are we good? Sarah?
Yeah.
Over that one.
So step 1 was to get everything to equal 0. Good to there, Bailey? I don't like having a -1 here. So I just multiply this half by -1, and then multiply the other side by -1.
Oh, okay.
So when you multiply, you get
Just
this.
for you to-
Good question. Everyone good? So now you factor. Oh, please, Ellen.
So x minus 2 and 6.
Nicely done. So now I know the intersection. So we good there? Okay, next thing, to do the integral properly, we need to know which function is on top, which is on bottom. There's a really easy way to figure that out. One of you will think of it. Like I've got this formula, y equal 4. I've got this formula, which will generate a whole bunch of y coordinates. I'm only interested in those points between x equal -1 and x equal 2. This one here. No, because watch me. X times x is x squared. X times 1 would be positive 1x. Negative 2x. You see it? Please, sir.
Would you just plug in a number and then?
Yeah, it's plug in a number. Take it. What number do you want to plug in? Somebody, come on. Let's go. Nice. A number between -1, x. We want an x value between -1 and between 2. What's the easiest x value to use between them? Here. Look at Braden's shirt. Nice. Perfect. 0. Thanks, Oregon, but you know. Okay. So plug in 0. So, hey, look, kind of a dumb question. This means the y coordinate is always 4, so there's nothing to plug in. But in some problems there will be. But the other one, I can find the y coordinate. So I say y is equal to negative, plug in 0. Oh, got it. So this curve has a point at 0, 6. The other curve has a point at 0, 4. So which curve is on top? The 6th one. So the picture looks like this then. There's a line, y equal 4. Again, exaggerating the fact that I don't totally really understand what this looks like, even though I kind of do because it's a parabola. So the other curve does whatever it does. Right? It doesn't really do that, but you know, it doesn't really matter. This point here, one person please raise your hand and tell me what is that x coordinate, what is that y coordinate? Not 0 this one. 4. 4. No worries. Take it for Bailey. Somebody raise your hand. Tell me what is this other x coordinate here, x and y coordinate there. Let's go, Sydney. 2, 4. And the one we found would have been kind of like here. 0, 6. That's why we knew the curve was on top. Pause for question. Please.
I'm confused what you're talking about on top and on top.
Oh, gotcha. It's all about the fact that when I want to figure out how to find the area, I'm going to take the y coordinate on the top, subtract the y coordinate on the bottom. So if the picture had looked like this, the y coordinate on the top is always going to be 4. The y coordinate on the bottom will vary depending on the formula.
Okay.
Does that make sense?
So if you plug in 0 and not like negative,
And that would
then
go
you
as
would use
the
y
curve to the bottom.
Okay. Essentially positive then 0.
It wasn't that it was positive, it was because it was greater than 4.
Okay, yeah.
Does that make sense? And again, if it's 2, please show me 2. But who feels good about what's on the board so far? Show me. Who feels good about what we've done so far to set up this computation to find the area? Take it from the room. Cool. Brave, please.
So, are you just, when you put in x equals 0, are you just trying to find like the top of the curve?
No, but good question. All I'm trying to figure out is I've got a line y equal 4, and I'd like to know, okay, I know the curve intersects twice. So that means the curve either does this or this. And I'm trying to figure out which. So I picked an x coordinate between, and I picked the easiest one, 0. And I know, like, right, in fact, right here, Braden, what's this xy coordinate right there? 0, 4. So I know the line's y coordinate. I just went and found the curves.
Okay.
And the key thing is, though, I know the curve doesn't do this. Somebody answer this question, please. Why do I know the curve doesn't do that?
There'd be another 0.
There'd be another intersection point over here. Take it from Heidi. So I'm not worried about that. So I know the curve either is above, whatever shape the curve, it really has a nice parabola, but whatever shape the curve has, it's above.
Okay.
But I'm not trying to find the center, the highest, or anything like that. Just one point to verify that it's above. Great question. Take it. Take it for Heidi. Anybody else? Okay, we're ready to set up the problem now. So now we just write the integral. We remember that the area is going to equal the area will equal the integral. We start at x equal -1. We stop at x equal 2. And we take the y coordinate at the top, subtract the y at the bottom, multiply by dx. We look at little rectangles here. We notice that every single rectangle The top y coordinate is always the same. -1 to 2. So someone tell me, how do we compute the top y coordinate of any rectangle within the area of interest? Ellie?
The equation that we were given to the top, and you plug that in, and then the bottom is 4.
Perfect. So looking at this area here, you notice that you can find the y coordinate at the top simply using that equation. So write that down. Negative x squared plus x plus 6. You subtract the y coordinate at the bottom, which is always 4. Multiplied by dx. To Ellie, question. First thing I would do is notice that 6 subtract 4 is 2. Please check.
So the negative x squared plus x plus 6 is not its own factor? That makes sense. So like, when I was writing it just without like looking up, I thought it would be like, so parentheses and then parentheses negative x squared plus x plus 6 close parentheses minus.
Got you. No harm in doing that. In fact, it's not a bad idea just to kind of remind yourself that that's one of the functions.
Yeah.
So you're thinking this, right?
Yeah.
It's just that I noticed that those two parentheses really don't do anything. The reason I think it's a good idea in Ticket is that when you subtract, if this were more than just 4, you have to have some parentheses. Yeah. To make sure you subtract the whole thing.
Yeah.
So it's a good comment. There we go. Now we do the antiderivative. So let's see, that's going to be negative x cubed over 3 plus 2x. Curses. X squared over 2, sorry. Plus 2. And that whole thing needs to be evaluated at x values of -1. Oh, curses. No. Curse. There we go. Do like the cartoons. Exclamation point, pound sign, asterisk.
Oh.
And then you just plug and chug. We finally got to plug and chug in calculus. Oh, you know, like, no plugging and chugging. Now you can plug and chug. That voice is very good. Great song. Good. All right. Questions, anyone? Awesome. Who knows? Chug. I think it comes from like old cartoons and stuff where the machine, they put something in the machine and goes chugga like that. It's really good sound effects now. It's on the video. Oh well. Raise your hand if you've listened to any of the videos. I'm just curious. You watched the video.
I should.
When you watch the video, can you hear the other students?
A little bit, not really.
A little bit.
Like asking the questions or just
Asking the question. Hopefully I'm doing a decent job of kind of restating the question, I hope. Can you follow the video? So it's pretty, okay, that's good. That's all. Good. It's right there. Oh, so. Anyway, it's been on for an hour. Very content. It's my legacy, you know. I brought it with me from Larson Davis, so it's very exciting. I helped build the damn thing, so.
Really? That's cool.
Helped design it. So. I probably actually soldered that one together because it was a prototype. So we were a really small company, only 50 people. So what I built was, so my job was to design the circuit board you see at the top of the bulletin board on the left, one with the big hole in the middle. The hole in the middle is for the batteries.
That's a microphone.
No, that's a circuit board that processes the signal from the microphone. So the microphone is not on the board up there. The microphone's actually only look at Ty's bottle, it's pretty close.
Where is
The microphone is about the size of that, just a little top thing. Like that's the microphone. Then there's a tube about the length of this. That's called a preamplifier. And the length really is not needed. The length is just so you get the microphone further away from the body of the meter itself. So here's the meter, right? The microphone sticks out like this. It's to avoid reflections, because it's meant to be a very precise measuring device. So you're supposed to put it in a sound field. It's supposed to measure the sound, but you don't really want sound to come and hit this and bounce back, because that would be artificially making it louder than it really is. Does that make sense? So when they use it in the spirit bowl, I don't really say anything because you're all having a good time, but when they hold the thing really close to your body, you're really helping the group. Like you can cheat a little bit. So if you hold it close to your body, the reflection will hit your body. In fact, if you wear like a nice, smooth, like armor or something, like you get the knight guy to wear his old-fashioned armor, that would help, because it would reflect off the armor and bounce back to the mic, make it louder. So anyway, so my job was to design that board. So I soldered the first one. You kind of build yourself to make sure it's working. So you solder them apart, test something, solder. So I probably soldered on that board. I can't remember. All right, here we go. Okay. Hand, please. There's something distinctly different about this problem. Help me. Come on. What's different? Hands. Ty knows. Who else knows? Come on. More people. I need more people. What is different about this than the previous? There's a lot of similarities, but there's something different. Annika's in. Come on. What is different? Amanda's in. Ellie, these are tickets. Your hand is raised. What? Amanda, what's different? Don't talk. No one else. Nice. Hey, big clue. It relates to Bailey's question earlier.
Mr. Smith, do you have Ashley Ellis in class?
Yes.
Will you please send her out front? She's being checked out. Thank you, sir.
Didn't even wait for a response.
It's all good. I don't really like responding, so. I figure yes is I'm good, so. I should just say when she says, is she in class, I'd say she's on her way, you know. Whatever. Moving on. No. Hey, how many noticed what Amanda noticed? That they specifically reference only worry about the first quadrant. Good. Ticket. There's something else really important about this one. Who notices it? It's different than all the others so far. Please, Sue.
Is it only equation?
Nice. The other one was an equation as well, but it was an equation that's easy to understand because it was just the equation. What did it say there? Y equal 4. So that one's easy to kind of visualize. These two are a little tougher to visualize, but the process is the same. We need to find where they intersect. So I set them equal. Write this down, please. So set them equal. Okay, once again, do not try to isolate x. You have an x cubed term and an x term, you're not going to be able to just kind of end up with x equal. So you want to get everything on the left and then factor. So somebody tell me what to do. Great, please.
So you subtract x and subtract 8.
Nice. So x cubed plus 8. Subtract x, subtract 8. It's going to equal 0. So we get x cubed minus x. Oh, baby. Somebody know what? Factor out an x. Take it for Braden. That's 2 for him. Somebody tell me what's left. Come on. Say it louder. Nice. X squared minus 1. You need to keep factoring where possible. Nicely done. Anyone have a question? That went crooked. It was looking really nice. Too low on the board right now. really comment on those points? Like what's important about them? Sarah, please.
Well, so it's gonna look like the kind of sideways S thing.
Yeah, nicely done. In fact, the first equation, x plus 8, is a line. So it's going to do something like this. And then Sarah is correct. The other curve is going to go like this, or perhaps the other way. I don't really know. There is one really, take it for Sarah, there's one really important clue that makes this problem a lot easier. Someone? Please, Lex.
The first quadrant.
First quadrant. So, because of that, I don't really care about this. This isn't in the first quadrant. So I can ignore that one. So really only 2 intersections. That's better. Take it for Lexi. I need to find which curve is higher and which curve is lower though. So someone remind, how do we do that, right?
You get a value of x in between 0 and 1 and plug it in.
Nice. Get a value of x between 0 and 1, plug it in. What value do you want, Braden?
What? Sorry.
1/2 is a good choice. It's in the middle. So we say, let's see, 1x equal 1/2.
Wait, so can you not put a 0?
Oh, because 0 is the intersection.
Oh.
No worries. If we plug, no, you just do it once, it kind of helps. So Sarah, if we plug in x equals 0 into this formula, what are you going to get? 8 into this formula? Right, that's because that's where they intersect. No worries. So we plug in x equal 1/2. So we get 1/2 cubed plus 8. Cubing something means to multiply by itself 3 times. So that's 1/8. So one of the curves has a point at 1/2, comma 8 1/8. The other curve is at where? 8 1/2. So which one is higher? That 8 1/2 one. So I've got 2 points. This one has a point at, let's see, 1/2, comma 8 1/8. This other one has a point at, let's see here, 1/2, comma 8 1/2. Okay, let's check through, make sure I need to explain something again. 1 or 2 if everything on the board makes sense. 1 or 2 if everything on the board makes sense. If there's anything that's fuzzy, just Ellie talk to me.
Why do you do like?
Oh, just because I want to emphasize we don't really need it. It really does intersect at x equal 0, not in the first quadrant. Bailey?
So if you're like drawing in a corner like the red and the green, are you supposed to know that one of them is a straight line and one of them is a curve? Like, do you have to know that?
Great question. I would say no. You don't have to. Because, let's see if this makes sense to you. They said it's in the first quadrant, so I do need to know what that means. Good there?
Yeah.
We know that there are 2 curves. They intersect twice. So for all we care, one curve maybe does this. I'm going to exaggerate a bit to answer your question. Maybe one curve is this. And the other curve can only intersect twice. So maybe it does this. I don't know. Does that make sense?
Yeah.
It's good enough to figure out the area because it doesn't really matter how I draw. The thin rectangles are always going to go from red to blue.
Okay.
Does that make sense? So you really didn't need to know. Because now you can write the integral by saying the area is going to equal. So at what point do I start the integral? 0. Where do I stop the integral? 1. What formula finds the y coordinate at the top of every rectangle? Say it louder, Lexi. X plus 8. Now here's Chad's advice. That parenthesis we don't really need. But the next one is essential. Like look here, like everyone else, your eyes on the board. The next parenthesis is required. You've got to have that one. Good work. See ya. Enjoy studying the presidents on Monday.